Hi everyone. Today let's move on to the last part of functional groups. The next functional group is ether. It has only one oxygen. There is no OH or C double bond O group as in the case of carboxylic acid, ketones, etc. So here we just have one oxygen group. This oxygen is sandwiched between two carbon atoms. It acts as a link between two carbon atoms, and the name of such compounds will end with ether. The example given here is that of ethyl methyl ether. That is, on the left hand side we have an ethyl group, on the right hand side we have a methyl group, which are both bridged together by an oxygen. The next functional group is amines. The general formula is RNH2. In the hydrocarbon chain, if you find an NH2 group attached, it clearly indicates that the compound is an amine. These amines can be classified into primary, secondary and tertiary based on the number of carbon atoms that are connected to nitrogen. They are generally named as alkyl amines. So the example given here is that of ethylamine. You find there are two carbon atoms which are connected to an NH2 group. So the name given is ethylamine. This is the classification of amines: primary, secondary and tertiary amines. If you find that only one carbon atom is attached to the nitrogen, then it is called primary amine. If you find that there are two carbon atoms attached to the nitrogen, then it is a secondary amine. And if there are three carbon atoms attached to the nitrogen, then it is called a tertiary amine. The next functional group is amide. So as in the case of amine, we will have an NH2 group. Along with the NH2 group, if you also find a C double bond O group, then we call it as an amide. The general name given is alkanamide. In the example given here, we find that there are two carbon atoms. So the root word used is eth. Since there is a C double bond O and NH2 group present, we add the suffix amide along with it, and the name given is ethanamide. The last functional group is haloalkane. They are nothing but halogens. When halogens are present in a hydrocarbon chain, we call them as haloalkanes. The general formula is Rx, where R can be any alkyl group and X can be any halogen. The example given here is that of chloroethane. We find that there is an ethane group, which is the R group here. There are two carbon atoms which are connected by a single bond. So it is nothing but ethane, and since there is a chlorine group present there, the name given is chloroethane. With this we come to an end of functional groups.